Resuming with summary and aggregate function. So we are starting with summary and aggregate function. Summary functions. So far we have learned reading data file, some methods to check the overview about the data and selecting data from a data frame. Those are not well enough information that we will get about the data. A data scientist always want to understand the behavior of data. For numeric column, we may want to know the mean value or the median of the data, the minimum value of the column, the maximum value inside the column, etc. For categorical column, we are interested to know things like number of different categories in the column, the count of each category in the column, the maximum occurring category in a column, etc. Here we will look some of the techniques that will help you to know the above information about your data. What is summary? Summary is a term used for short version of longer work. Summary is a brief statement of the main points of something. Confusing, let's understand through an example. Summary function. Panda has many simple summary function. Well, this is not an official name that helps you to restructure your data in a very useful way and display a useful information about data. Do you recall the info method that we had used earlier in the module? This method has given us 6 to 7 main points about the data, like number of observation and the range of indices, name of columns with their data types, and number of non-null entries in the particular column, etc. So info is a summary function or method. Here we will see another summary function described. Import pandas library, load the dataset exam underscore score.csv. So we will have a statement import pandas as PD. We will read exam underscore csv file, convert it into a data frame using pandas.readcsv function and store it in a data frame name exam underscore scores. The describe method by default returns the summary about your numerical columns only. So exam underscores score.describe will give you a count, mean, standard deviation, minimum value, 25th percentile value, 50th percentile value, 75 percentile value, and maximum. Now, when you arrange your column in ascending order and take a point at 25th percent index, then it will be 58. At 50% of index, it will be 67. At 75% of index, it will be 78. Minimum value and maximum value. If you want to get the summary about categorical column separately, then we can use option one parameter include. So exam underscore score dot describe, in opening and closing parentheses, we will give you a keyword argument include is equal to object. So this will give the summary of categorical variable wherein you will have count, number of unique values, top value, and the frequency of the top value. Like gender, top value is female, frequency is 503, 502, race and ethnicity. Race and ethnicity, top value is group C, and frequency is 294. Patient level of education, same college, 226. Lunch standard, 649. Test preparation course, none, 654. The written summary is all about categorical columns. Don't worry if you don't know what does the term in red box means. You will know the meaning of these terms in further slides. So also we can get summary about numerical and categorical column together using the same parameter include. Exam underscore score dot describe include all. It will give the summary of all the columns present inside the data frame. Don't worry if you don't know what does these terms in the red box means. The terms are explained in next two slides. So Data frame dot describe function include is equal to all will give count, unique, top, frequency, mean, standard deviation, minimum 25 percentile, 50 percentile, 75%, and max value of a column of data frame. We can see about table includes the summary about both numerical and categorical column. A categorical column cannot have minimum or maximum value or mean and median, so that entries in this field for categorical column is null. We had seen in the previous module that the dataset has 5 categorical values: gender, race and ethnicity, parental level of education, lunch and test preparation course, and 3 numerical, that is integer columns: math score, reading score, and writing score. So, understanding the terms above: gender, race, ethnicity, parent level education, lunch, test preparation course, math score, reading score, and writing scores are column names. Count. Count the non-null entries of both numerical and categorical value. Unique. Only for categorical columns, how many unique distinct values are there? Top. What is the highest frequency value in that categorical column? Frequency. The count of repetition of that top value. So for example, top value is female, frequency is 502. Mean is the average. Standard deviation, we compute standard deviation by a formula where it shows how the data points are away from the mean. Minimum value, 25th percent value, 50% value, 75th percent value, and maximum value can be retrieved. Okay. Let's see what the information about data is written in the above table. Count. The count of non-null entries of the particular column, for example, gender column has 1000 non-null entries. Unique. The count of unique values in a column only for the categorical column. For example, gender column has 2 unique values, male and female. Top. This is also for only categorical column. This tells which category is occurring maximum number of times. For example, gender column is occurring maximum number of times. Frequency. This is again for categorical column only. This tells you the number of occurrence of category that is occurring maximum number of times in the column. For example, female in gender column is occurring 502 times. Mean. The mean value of a numerical column, for example, the mean math score is 67.128. Standard deviation, STD. This is the standard deviation of numerical column. This tells about the variation of the data. Minimum. The minimum value of the numerical column, for example, the minimum value of math score is 15. 25th percent. The 25th percentile or first quartile value of the numerical column, for example, 25th percentile value of math score is 58. The 58th percentile or second quartile or the median value in the numerical column, for example, median of math score is 67. 75th percentile, the 75th percentile or the third quartile value in the numerical column, for example, 70th percentile value for math score is 78. The maximum value of the numerical column, for example, the maximum math score is 100. NaN value means for a particular column in a particular summary, value is not available. For example, for column gender, a categorical column do not have mean value or median value, as these are the properties of numerical column only. We can also use describe method on a particular column or series. Exam underscore score in opening and closing square bracket, name of the column dot describe function. So for a single column, which will be treated as a series, if you extract it, we can run the describe function on it. So here we have run a describe function on numerical column and categorical column. So exam underscore scores in opening and closing square bracket, math score is a numerical column. So we have run a dot describe function on the numerical column, which will give count, mean, standard deviation, minimum value, 25% value, 50% value, 75% value, and maximum value. Then in the second example, we have done exam, exam underscore score, in opening and closing square bracket, single quotes, you can use gender. After gender, dot describe function. As gender is a categorical column, the values written by the describe function is count, unique, top value, and frequency of that top value. If the column name doesn't contain any space in it, then you can use the attribute styling selecting of column. So gender does not contain space, so you can write exam underscore score dot gender also. And for gender dot, you can call describe function. Otherwise, you can use this syntax wherein you are in square bracket, you are giving the column name. For example, we use attribute style for selection of gender, but not match score as it contains space. So in this examples, we have run describe function on the single column of the data frame. If the column name doesn't contain any space in it, you can use attribute style for selection of a column. For example, we use attribute style for selection of gender, but not for match score as it contains space. If you use attribute style of selection of match score, Python will throw an error. So in this example where you write exam score dot match space score, there will be an error, invalid syntax. Now, aggregation function, we saw the use of describe method on a data frame on a series which returns some information about the data. We can also use individual method like mean, median, unique to get those information on the data frame or a series. Examples shown in the next slide, that exam scores dot mean will give the mean value for all numeric column. Exam score dot gender dot unique will give you the unique values of the gender column of the data frame. To see all the unique values and the number of times they have occurred in the data set, we can use a method values count. So exam score dot gender dot values underscore count will give the count of unique values present inside the column of data frame. So our column is gender. For gender, we have unique value female and male, and count of unique value is 502 and 498. So female is occurring 502 times in gender column, which we see in the table written using the describe method. Now, solving the question on aggregate function and summary function. So we will use the same standard metropolitan area dataset. The above link will give the link of the dataset. What we have to do, we have to import pandas library in our notebook. We have to read the dataset using pandas library read CSV function and store it as a name SMA underscore data. This can be done by following statement. So moving to our notebook. Inside the notebook, we have already imported the dataset using the statement. This statement, Control A, Control C, move to the next cell, new cell. We have read SMA underscore data using pd.read CSV function. And in opening and closing parentheses inside the double quotes, we have the link of the dataset. When you click on the cell and run the cell, SMA underscore data is available inside SMA underscore data variable. Use mean method on the data frame SMA underscore data and select the correct statement. So we have to run the aggregate function SMA underscore data dot mean. This will give the mean of all the numeric variable of the data frame, and then we can answer the question. The mean of the column LAN area is in the range 26150 2616. So LAN area 2615 and 2616, correct. The mean of the column income is in the range 6762 6763. Income 6762.5 means it is between 6762 and 6763. Second also correct. Both are correct. Use unique for column region. How many unique values are there in the column? So we will use SMA underscore data dot region attribute method of selecting the column. Run the unique function. As it is categorical data, it will return all the unique values. So unique values are 1, 2, 3, 4. We can say how many values? 4 values were written. Select the correct statement about SMA data. Okay. Int summary function describe for us humans 969 and 969 are same. So for SMA underscore data, column name is, you have to run the describe function. So dot describe, which will give the summary statistics, and then we will answer the question. The minimum income is 769. So we will see mean of income variable. So you have 769, which is correct. The maximum crime rate is 85.62. So max of crime rate 85.62. The median land area is 1951. So we will see 50% of land area 1951. There are 99 non-1 values in the workforce column. So we will go to the workforce column, count non-none values are 99. All the above statements are correct. Select the observation from the data frame SMA underscore data where the region is equal to 3. Okay. Name the selected data as sample data 1. Select the correct option for sample data 1. So we will filter this data SMA underscore data. What is the filtering condition? You have region is equal to 3. So dot region should be equivalent to 3. Now you have to return the data of this condition on the same data frame. So SMA underscore data will be written again, and this result is to be stored inside a new variable SMA underscore data. Name of the variable is sample data. So here you will write sample underscore data 1. So we have filtered the value. Let's run the describe function. Sample underscore data 1 dot describe. This will return the summary statistics, and then using the summary statistics, let's answer the following question. There are 36 observations. So for observation, we have to run the info function. So sample underscore data 1 dot info function. So here you can see 36 entries. Therefore, we have 36 observation. The mean crime rate is 58.0 to 58.4. So we will see mean of crime rate 58 0.26, which is between 58.0 and 58.4. There are 30 non-null values in column graduate. So we will go to column graduate, and there are 36 non-null value. So this is incorrect. All the above are correct, only 1 and 2 are correct. So only 1 and 2 are correct. Now, count the occurrence of unique value in column region of the data frame SMA data. So SMA data, and for region, we have to get the unique value. Select the correct statement. You have to use the function value count. So on SMA underscore data dot region dot value underscore count function. It is throwing an error. So spelling value counts. Here it should be S, and you have the value count. Now the maximum occurring region is 3. So 3 is maximum. Yes, it is correct. The minimum occurring region is 2. So 2 value is 25. So minimum occurring region is 17. So second is incorrect. The region 4 is occurring 17 times. Region 4 is occurring 70 times. This is correct. So 1 and 3 are correct. Click on the cell, submit your answer. You can see all the 5 answers are correct, and then we can move to the next part. Function available to enter full screen mode. Sorting. Now we will see sorting. Assume you are a teacher and you have to score your student in the dataset exam scores. You want to get the information about all the student whose performance is very bad in maths. What about going through all the records in the dataset and finding out manually the student who scores math is very bad? This will be very time consuming. So you can think doing this manual task if you have 10 or 20 records. But here you have 1000 records. You need to figure out some easy way to do this. Here comes the importance of sorting techniques. The data present inside the data frame exam score is in the default index order, not in the value order. Pandas provide a method called sort values, which returns the sorted result in value order. So let's say you want to get student information which are in increasing order of math score, then you can run data frame dot sort values method in opening and closing parenthesis by is equal to, and you give the name of the column by which you want to sort math score. Dot head represents you are representing the first 5 rows of the result. So when you see math score, they are sorted in ascending order. Minimum score is 15, after that is 18, then there is 23, then 25, 25. By default, sorting happens in ascending order. So exam score dot sort values by is equal to math score, by which column you want to sort your data frame. So data are not in index order, sorted in ascending or increasing order of math score column. We can get the sorted result in decreasing order by passing parameter ascending as false in the sort value. So exam score dot sort values, inside it you will pass a keyword argument by is equal to math score, comma keyword argument ascending is equal to false dot head. Here your scores are sorted in descending order of the math score. We can sort a series using the sort values method. So exam scores, math score, a single column of your data frame dot sort values method Inside sort value method, we are giving a keyword more argument ascending is equal to false. So they are sorted in descending order, and we are printing first 5 rows of our result. Therefore, in front of it, we have slicing, opening and closing square bracket. You don't have any value at the start, means it will start from the first index, colon 5. So it will run from 0, 1, 2, 3, 4. So for first 5 values of your sorted resultant result will be printed on the user screen. Now, renaming a data frame. Renaming means changing the names. Most of the time we get the data set where column names are not satisfactory. For example, in data set, the math score, reading score and writing score contains spaces in due to which we are not able to use attribute dot selection style method to select a particular column. And not only this, if the column names were MS for math score, RS for reading score, and WS for writing score, this is not satisfactory column name. The need of renaming a column or index comes here. Pandas provide a function rename to rename the column or index in a data frame. So let's rename all the column name of the data frame which contains spaces in it. Also, we will rename the column race oblique ethnicity to race. So we have to call exam scores dot rename function. Inside opening and closing parentheses, we have to give columns to access all the columns is equal to, we would pass a dictionary, which is a key value pair. So inside the key value pair, keys are the old column names and values are the new column name. For example, race oblique ethnicity will be renamed by race. Parent level of education will be renamed by parent underscore education underscore level. Test participation course will be renamed by test underscore prep underscore score. Math score will be replaced by maths underscore score. Reading score will be replaced by reading underscore score. Writing score will be replaced by writing underscore scores, comma, in place will is equal to true will make the changes in the original data frame. So when you print all the columns of the data frame, exam score dot columns, you can see the renamed column printed on the user screen. If you see the first 5 rows of the data frame using the head method, then you can see gender, race, parent, education level, lunch, test preparation score, math score, reading score, writing score. First 5 rows displayed on the user screen. So these are the change of rename columns. Race, parent education level, test preparation score, math score, reading score, and writing score. We can also rename the indexes of the data frame using rename function as shown in the image. So in the previous case, we were using rename method. In this also, we will use rename method, but we will rename the indices, is the row names. So index is equal to, inside it in opening and closing brace, we will pass a dictionary in which we will give the key value pair, where key will act as a index value which is to be changed, and value will be the new value which is assigned to that index. So 0 is a given name string, 1 key is given name 1, 3 key is given name 3. And out of all this result, we are printing head, means we are printing first 5 rows of the data frame. So you can see at 0th index it is 0, at 1 index it is string 1, at 3 index it is string 3. After renaming, older data frame was looking like this. After printing the new data frame, you have 0, 1, 3 as a string represented on the result of the data frame. Now, moving to the hands-on part, the first part is same. You have to use standard metropolitan area dataset. From this link, we can get the dataset. You have to open the notebook and answer the following question. First task is input pandas library in your notebook. Read the data frame using pandas library read underscore CSV function. Name the loaded data set as SMA underscore data. And this can be done using this statement. So we have done this previously. Moving to our notebook, we have read SMA underscore data from the given link using pandas.read CSV function. So again, executing the cell, we have read the standard metropolitan area dataset CSV file and stored it in a variable SMA underscore data. Sort the data frame by crime rate in descending order. So you have to run the sort method. So you will write SMA underscore data dot sort, press shift tab, a question mark. We'll check the syntax for sort method. So to check the syntax, we will move to sorting. Go to the method name. It is sort underscore values. It is sort underscore values. Sort underscore values. Inside opening and closing parentheses, we have to use the column name. So by what is a column name they want us to sort on? So moving to the questions. Here, crime rate. So check the name of the column. So press escape B here. SMA underscore data dot head give you the column name. The name of the column is crime rate. So we will copy this name. Here in single quotes, we will give the name crime rate. This is first keyword argument. Then we will give another keyword argument. Ascending is equal to false. Cross check the syntax. So we will move to sorting, check the syntax. Ascending is equal to false. It doesn't contain single quotes. This will return a data frame and we will print the first five values of the data frame using the head function. Okay, now we have sorted it. Now let's go through the question and answer it. What is the question asked? The first five observation of the data frame sorted data one has the same region. Which is that region? So we will check the region. Region is 4. So answer is 4. Which method is used to rename the column or index? Rename method. Which of the following set of code will help you to rename the column physician in the original data frame? So sm.data here columns is equal to physician and colon key value pair num physician comma in place is equal to true. So here these two are same. Sm underscore data rename columns columns physicians, num underscores physician, in place is equal to true will be the correct answer. Okay. Here, this will also enable us to rename, but it will not reflect in the original data frame. So first option will be true. Click on the cell, run the cell, you got a score of 3 and 3. 1 and 3 was the correct syntax, but 1 was updating in the original data frame, therefore it was sufficing the question. Moving to the next part. Now, this is important. When you get a data frame and you want to work on the data frame, you have to handle the missing values. So, handling missing values or missing data. So, if in any row or column of data frame the values is not available, it is set to be as missing value. So, defining missing data or missing value is defined as the data value that are not stored in the column or rows. So consider a small data set which has following missing values in it. So this data will registration number, name, marks, percentage has a fifth index wherein you don't have a name and marks percentage. Well, this is small data, so we can easily observe the missing value here. But real data are very large in size, so you cannot easily see the missing values in the data frame. So pandas provide is null or is NA function to detect the missing value. Both of them do the same thing. df dot is NA or df dot is null returns the data frame with boolean values indicating missing values. So df dot is NA will show true where the null values are present, or df dot is null will show true where the missing values are present. True means these entries are missing from the data. Now, we can get the column-wise count of all the missing values using the aggregate function sum. So we have to run df.isNull.sum. So this will give the missing value count. Name has one missing value and mark percentage has one missing value. Both the columns name and marks percentage have one missing value in each. Registration number has a missing value, so the value is 0. Has no missing value, therefore value is 0. Pandas allows providing fill array method to fill missing values. So fill array provides many different strategies to fill the missing values. Let's say we want to fill the missing value in name column with unknown. So we will write data frames dot names dot fill array in opening and closing parentheses in single quotes unknown. So all the null values will be filled by unknown string, but the changes are not made in place, means they will be printed on the user screen but not reflected in the original data frame. To reflect the changes in the original data frame, we have to give a keyword argument in place is equal to true. So you, in this example, you can see data frame dot names dot fill array in opening and closing parenthesis unknown. So when you print a data frame, again you have the missing value at the same column. So if you pass data frames dot name dot fill array unknown comma in place is equal to true, then the names column missing value will be replaced by unknown. This missing value is filled with unknown. There is still a missing value in marks percentage column. Let us say we want to fill the missing value in this column with the mean of the marks scored by other student. So using aggregate function data frame df in opening and closing square bracket marks percentage dot mean will return the mean value of mark percentage column. Then data frame dot marks percentage dot will run the fill array function. Inside the fill array function, we will pass df marks percentage dot mean. So the missing value will be replaced by the mean. Comma in place will is equal to true will reflect all the changes in the original data frame. So when you print the data frame, now you can see both the missing values of name variable as well as the mark percent variable which were filled. Name variable were filled by a string unknown and mark variable was filled by the mean value or aggregate value. So our little data frame does not have any missing values. Now, running the hands-on exercise on it. So same, first thing is same, you have to load the, now in this case, you have to load the Titanic dataset. So in this set exercise, you will work on Titanic dataset. The above link is raw GitHub link. Open a notebook and answer the following question. Task is import pandas library in your notebook. So we have already imported it. Read the data using pandas library, read CSV function. Name the loaded data set is Titanic data. So data frame which will be created will be Titanic underscore data. To read the data, pass the GitHub link inside the read CSV function. For example, you can see the image below. So you have to run this statement to get the Titanic CSV data set inside your notebook. So pd.read CSV function in opening and closing parenthesis in single quotes, link of the data set that will be stored in Titanic data. So Titanic data variable contains the Titanic data set. Now, check the data set has any missing value or not. If there are any missing value, which of the following columns are they? If there is no missing value, then select the last option. So we will see Titanic underscore data and we will run the is null function. Yes, some of places there are missing values. We will see is null dot sum, apply the aggregate function. Then you can see there are missing values in the age column as well as missing value in the cabin column. So you can see age is the first and cabin is the third. So you only 1 and 3 is the answer. Find the mean of age column and assign it to the variable age mean before. Fill the value of column age with the mean value, that is age mean before. To calculate the mean, you can directly use the mean method on the age column. After filling the missing value of the age, find the mean of the column age again and assign it to age mean after select the correct answer. So we have to compute age mean before. Click on the cell, copy age mean before is equal to dataset name Titanic underscore dataset. We want age column and of the age column it is capital AGE. If you want to run which function? Mean function. This will give you the mean. So we will print age mean before. You have mean as 29.699. Now we have to fill the missing value of Titanic age function. So for Titanic underscore data for age, we have to run dot fill any and we have to fill it by age mean before. You have to pass a keyword argument in place is equal to here. Now it is correct. Now we have to compute age mean after. So you have to compute age mean after. This age mean after is the mean of the updated data frame. So Titanic underscore data dot for the column age you have to run the aggregate mean function and print age mean after. So age mean after is 29.69911. Again, the age mean after is same. Now we will go to the notebook and answer the question. The mean value before filling the missing value and mean value after filling the missing value are same. Consider up to 2 decimal points both the cases. Yes, 6969. Yes, first is true. The mean value before filling the missing values and mean after missing values are not same. Consider mean value. So first statement is true. Moving to the next question. Find the maximum occurring value of category or category in column embarked. So hint value counts we have to use. Fill the missing values in the column embarked with the maximum occurring value. Select the correct answer, correct statement. So for the Titanic dataset, Titanic underscore data, we have to access the embark column. So it does not contain any space, so therefore dot embarked. Then we have to run value underscore counts method. So maximum occurring value is 644, which is for S. Now what the question says, fill the missing value in the column embark with the maximum occurring value. So again, for Titanic set embark column, we have to call fill any method. Inside it, we have to replace the missing value by 644 and we have to pass in place is equal to true as a keyword argument. We have filled the value. Now we will answer the question. The number of occurrences of category R's after filling the missing value before filling the missing value are same. So again, we will take the value counts after filling the missing value and they are same. The number of occurrence of category C after filling the missing value before filling the missing value are same. For C, 168. The number of occurrence of category Q after filling the missing value and before filling the missing value are not same. So for Q, it is 77, and for Q, there is a incorrect. I think the syntax is incorrect. So we check the syntax, submit the answer. So 1 out of 3, we got 2 correct. Cross checking it, the first question. There are 3: embarked, cabin, and age, which contain missing value. So all of the above. This was correct. We have to check for categorical data how the missing values were filled. So moving to the slides, checking and filling the missing value, we will see one example of how categorical variable missing values were filled. So we ran isNull.sum, that is okay. Fill any method. Syntax of fill any method is unknown. Fill any unknown. Okay. Unknown. mean in place is equal to true. So as it is a categorical data, suppose we fill it by df. So you have to give the column name here, df dot marks dot mean, or you have to give the direct value unknown. So we give it a value s. Now run the cell. You have to run it from start. Take the Titanic data set. We have 3 age before mean. After filling, age is same. Now you can see the result is updated as s is equal to 646, c is equal to 168, and q is equal to 77. It was a categorical data containing element s, c, and q. Therefore, we have to use s instead of 644. That was our mistake. Now we can go and answer our question. So exercise on hands-on on categorical value. So number of first is there are 3 columns, age, cabin, and embark, containing missing values. Mean before and mean after are same. Third is number of occurrences after filling the missing value and before filling the missing value are same. So category S, this is not the case. The number of occurrence of category C after filling the missing value and before filling the missing value are same. This is incorrect. C is correct. Q, the number of occurrences of category Q after filling the missing value and before filling the missing value is not same. Q is same, C is same. One of the statement. None of the above are correct. Submit. Okay, I find problem in this question. You can raise an error on this question because you can ultimately check your result and it is a number of occurrence of category C after filling the missing values and before filling the missing values are same. Yes, the number of occurrence of category Q after filling the missing values and before filling the missing values are not same. Okay, this is the answer. Are not same. This is correct. This is incorrect. This is incorrect, and this is correct only. So only one statement is correct. So retry it. You have 3 missing values: age, cabin, and embark. So only 1 and 3. All of the above. Average before and after is same. The number of occurrences of category S after filling the missing value and before filling the missing value are same, incorrect. The number of occurrences of category C after filling the missing value and before filling the missing value are same. For C, they are same. For Q, they are not same. So only statement 2. Yes, this is correct. Moving to the next part. Now this is optional. You can go through the session, deep dive into pandas by Sarvananda Jayachandran, co-founder of BitCrunch. So he's a data scientist. You can go through this session, good session to do on data science, pandas library. By this, we completed the course on introduction to pandas. You can get this notebook by clicking on the link. This showing us that we have not completed a session. So we will cross check which session we have not completed. We have completed data analysis, We have completed introduction to pandas. We have completed series data frame and exam. We have completed read write hands-on exercise. We have completed indexing and selection. We have completed summary and aggregate function. We have completed sorting and renaming. We have completed checking the missing value, and we have completed live session on pandas. So we have completed, in all, we have completed the course. Thank you. Thanks for watching. Do hit the subscribe button if you like the content, and see you in the next video.